Hi guys, this discussion is all about properties and changes in matter, and this is discussion 2-2. So as I go through this video, make sure that you're filling out the discussion sheet. That way, this is your notes, right? So this is your notes on properties and changes in matter. So the first thing I want to look at is how are physical properties different from chemical properties. So physical properties are something that you measure or observe without changing the substance. So what that means is you're observing something without actually changing what the substance is made of. So if I'm observing this pen, I can say this pen is red. Okay, I'm not actually changing the composition of this pen. I'm just looking at it. Okay, so you're measuring or observing it without actually changing the substance. Okay, so if I were to write with this pen, I would say the ink is red. Again, I'm not changing this pen into water or, into a highlighter. It's still the pen. So some physical properties, these are some examples. State of matter, solid, liquid, gas. Those are physical properties. Anytime that you are changing a state of matter, okay, that's still physical. So like boiling point, melting point. As I'm looking at melting point, if I were to get an ice cube out of the freezer that's made of water, if I were to set it on my desk or set it on a lab table and leave it there over the whole weekend, it would still be water when we came back on Monday. So I didn't change what the water is made of, I just changed how it looked. That's state of matter. Color is another one. Solubility, that's the ability of something to dissolve. When I dissolve salt in water, I'm not actually changing the water and I'm not changing the salt because I made a mixture. Right? I can get the salt back out of the water by boiling off the water. If something is magnetic, that's another physical property. Smell. Okay, so if I were to, take the lid off this highlighter and smell it and I say, oh, this smells good, right? I'm not changing the highlighter. I'm just observing a smell. Density is another physical property. We're going to talk much, much more about density in the next part of the unit. We're going to do a whole section on density. That is how much mass we have per volume, right? How dense something is. A lot of times you think about if it floats or not. Okay, that's a physical property. Chemical properties change the substance completely. So flammability, that's the ability of something to catch on fire. So if I wanted to determine if this pen is able to catch on fire, I would have to actually light it on fire. I would be changing this substance. It would no longer be a pen. It would be, maybe a pile of ash. Or maybe I would be changing the plastic. Okay, and then reactivity. So reactivity is a chemical reaction. Okay, if it's ever a chemical reaction that takes place, you're observing a chemical property. So how do we know when a physical or chemical change occurs? Well, a physical change is when we have the same substance. So if I'm just changing the state of matter, right? I still have water, it just looks different, right? But it's still water. A physical change is also easy to reverse. So if I can easily reverse what I've done, it's more than likely a physical change. So examples are phase changes, right? Solid to liquid to gas. Those phase changes are physical changes because I'm not actually changing the substance. So the only difference between property and change is properties are things that we observe. Changes are an actual process that takes place. So dissolving, that's a physical change because we can still get the salt back out of the water or the sugar back out of the water. In a chemical change, okay, you can make a note above chemical change, that's chemical reaction. If it's a chemical reaction, it's a chemical change. So in a chemical change, we formed a new substance. So we formed something completely new. And chemical changes are not easily reversed. Okay, they're not easily reversed at all. And then we have ways to tell if we have formed a chemical change. So some examples of chemical changes are rusting. That's a chemical reaction. Cooking something. Burning something. What else would we have? Mixing things and forming a solid, right? That's an actual chemical reaction. So here are things to look for. So these that are in red are your evidence that a chemical reaction or a chemical change took place. So you had a color change. if a gas was produced. So that's if you see words like bubbles or fizz. An energy change, which means maybe temperature changes, you see light given off. If you have an odor, right? So you have a smell. Or if a precipitate is produced. And a precipitate is just a solid. So these two right here kind of go together, right? Precipitate means solid. So if a solid is formed when you mix two things together, that's a chemical change. These 5 pieces of evidence right here are what you should look for to determine if it's a chemical change or a physical change. So here are some more examples of physical and chemical changes. So when you dissolve something, right? So if I were to dissolve copper chloride, which you're going to actually look at pretty much this entire slide, you're going to look at in lab. So dissolving copper 2 chloride, that's CuCl2. If we mix salt and sand and water together, that's a physical change. If we mix two things together, right, so if we just mix two things, that's a physical change. Chemical changes, though, is if we actually heat up this mixture that we made, something new is formed, right? Or if we burn magnesium, that's a chemical change, and you're going to see why. If we add this copper 2 chloride and aluminum together, that's a chemical reaction. Okay, so I want you to keep in mind chemical changes. You want to look at those 5 pieces of evidence to determine if a chemical change took place. Throughout physical and chemical changes, we always have to follow what's called the law of conservation of mass. And the law of conservation of mass says that mass is not created or destroyed in any change, whether it's physical or chemical. Instead, our particles just rearrange. So the mass before, which is our reactants, always is equal to the mass after, which is our products. So if we were to add 2 elements together to make a compound, so iron plus sulfur, and I added 0.5 grams of iron and 0.2 grams of sulfur, if I start with 0.7 grams over here, I have to end with 0.7 grams here. But notice I've formed something completely new. I no longer have 2 separate elements. I now have one compound. They're chemically combined. That's different. That's a chemical change. So then what these next questions have you do is they have you actually look at states of matter. So we need to list the states of matter from lowest energy to highest energy. So what I want you to think about is the first discussion that we did when we talked about solids, liquids, and gases and those particle diagrams that we looked at. Which state of matter moved around the most and bounced off of the walls and the other particles? The gases. So gases actually have the highest level of energy. So gases are going to have the highest. Okay, so gases are going to have the highest because, and this is going to kind of answer number 6, gases have the highest level of energy because they move around the most. They bounce off of each other the most. So then solids are going to have the least energy, okay, because they don't really move at all. So it's all about movement. And then liquids in the middle. Okay, so different states of matter have different energy because they're moving different amounts.